Okay, so if you're a professional, you've probably felt this tension, right? You want to use these incredibly powerful AI tools, but you're also dealing with confidential client data, secret M&A details, or your company's internal strategy. Well, the good news is you can actually have the best of both worlds, and the key to it all is a local-first approach to privacy.
I mean, this is the question, isn't it? How do you use AI for your really sensitive work without just handing over all those sensitive details? You need its help to analyze a contract or prep for a huge meeting, but the idea of uploading that confidential document to some third-party cloud? Yeah, that's a total non-starter.
So the answer here isn't just some long privacy policy that you have to cross your fingers and trust. No, it's actually built into the very architecture of the software. We're talking about a fundamental, deep-down difference in where your data lives and how the AI is even allowed to access it.
All right, so let's break down the two main ways this can work. On one side, you have cloud first. This is how most AI tools operate. You send your data up to their servers for processing, which means it leaves your control. But on the other side is the local first model. And this is a complete game changer, designed from the ground up to keep your data on your device by default.
Okay, so let's actually follow your data on its journey. It's so important to understand exactly what stays right there on your computer and what, if anything, is sent to the AI for processing. Let's get transparent.
At its core, local-first architecture just means the app's home base, its center of gravity, is your computer, not some remote server. And this isn't just a setting you can flip on or off. It's the entire design philosophy. Your data, your files, your credentials, they all live with you.
First, and most importantly, your files. I'm talking about your entire workspace, all your project folders, documents, notes, they all stay put, right on your local machine. The AI does not get a free pass to browse your hard drive.
Next up, your security credentials. Any API keys or passwords you're using are stored securely right in your local application settings. They are never uploaded, never shared, and never stored in the cloud. Period.
And this same principle applies when you connect to other services. When you hook up something like Google or Slack, the app uses a secure, unique token, so it never even sees your actual password. Then that token gets stored locally on your device, giving you that secure access without ever exposing your main login details.
So what actually does get sent? It's really simple. Just two things. First, the text of the conversation you're actively having, and second, the content of any files you explicitly attach to a message, like when you drag and drop a file right into the chat. And that is the crucial point here. The AI never accesses your files unless you deliberately hand one over for a specific task. You are always in control.
Okay, so the default setup is already super secure. But what about those times when you're working on something truly confidential? Stuff where you can't risk even a single snippet of data leaving your machine? Well, for that, there are advanced strategies that give you even more control. For those highly sensitive situations, you have two incredibly powerful strategies at your fingertips. Both of them let you get that high-level strategic help from the AI without ever sharing the sensitive details themselves. The first strategy is called privacy mode. Think of this as putting your AI assistant into manual transmission. When you toggle it on, absolutely nothing happens without your explicit permission. The AI will propose every single action it wants to take, and you are the gatekeeper. You approve or deny each step before it runs. It's the ultimate safety. The second strategy is the abstraction method, and this is brilliant. Instead of giving the AI your confidential data, you describe a generalized, abstract version of your problem. So as you can see here, you don't ask it to review the specific Project Titan term sheet. No way. Instead, you ask for a framework to assess a deal like it. This way, you get the AI's high-level strategic thinking without revealing any of the confidential particulars.
And that really gets to the heart of this philosophy. The goal is to get strategic coaching from the AI. You're using it as a sparring partner to help you think through problems, not as a data processor that needs to see all the raw, confidential info.
Now, we've made a lot of claims here about local data and privacy, but we believe in radical transparency. So let's show you the proof, right on your own computer.
Check this out. This is what happens even in the rare case you need to generate a diagnostic log for support. Look at this table. The most sensitive data, API keys, OAuth tokens, passwords, are always automatically redacted. They're literally scrubbed clean before the log is even created. This is what privacy by design actually looks like.
And for the ultimate proof, here you go. These are the exact file paths where the application data, your settings, your conversation history, your secure tokens, lives on your computer. It's not hidden. We want you to see it.
This transparency empowers you to go and verify for yourself that your data is stored locally, right where it belongs. So, when you put it all together, what does this all really mean? It means privacy isn't just a setting you toggle, it's a combination of a secure by default architecture and the deliberate choices you can make.
Because at the end of the day, local-first architecture isn't just another feature on a list. It's a philosophy. It's a fundamental commitment to the principle that you should be in complete control of your most important confidential work.
So that leaves just one final question. Now that you know how to leverage AI safely, now that you know exactly where your data lives and that you're in control, what's the first confidential problem you're going to solve?